Introduction. In the current usage, the term remote sensing generally refers to the use of satellite or aircraft-based sensor technologies to detect and classify objects on Earth, including the surface and in the atmosphere and the oceans, based on the propagated signals, for example, electromagnetic radiation. In the previous chapter, we have discussed about various definitions of remote sensing and the history of remote sensing. In this chapter, we will discuss about types of remote sensing, components of remote sensing, future of remote sensing data products. Types of remote sensing. Remote sensing can be categorized into various types based on different parameters. Based on classification of platforms, remote sensing can be divided into ground-based remote sensing. These are also known as terrestrial platform because they remain in contact with the ground. During the meeting of the Earth's surface, the platforms are on the ground surface, including the mobile van mounted sensors. Airborne or suboptical remote sensing. The platforms are within the atmosphere. For example, kite, balloon, aircraft and even rockets are commonly used to collect the very detailed images. Aerial photographs have been a main source of information about the Earth's surface almost since the beginning of aviation from a century ago. Spaceborne or orbital or satellite remote sensing. The platforms are the space example satellites. Sometimes International Space Station in the Space Shuttle are also used as platforms. Satellite remote sensing can significantly enhance information available from traditional data sources because it can provide synoptic view of large portion of the Earth. Based on energy source, remote sensing can be divided into passive remote sensing. The sun's energy is reflected or emitted from the Earth's surface feature is recorded. When the sun's energy source is used for remote sensing, it offers passive remote sensing, such as UV images, visible NIR, spectrometers, thermal sensors and microwave radiometers. As the sensing is depending on the sun's energy, it can record images only in daylight. The other type is active remote sensing, when sensors provide their own energy source for illumination and radiation reflected or emitted from the target is detected by the sensor. These sensors can sense the imaging in day and night time also. Based on imaging media, remote sensing can be divided into photographic imaging. Photographic imaging uses chemical reactions on the surface of the light sensitive photographic film to detect and record energy. Digital images. The reflected or emitted energy is imaged electronically by electric transducers, for example, with coupled devices. Based on the regions of electromagnetic spectrum used, remote sensing can be divided into optical remote sensing, where optical remote sensing involves the use of visible part of the electromagnetic spectrum. Main source of energy for optical remote sensing is emitted by the sun, where the visible spectrum wavelength ranges from 0.382 to 0.79 μm. The human eye has physical sensitivity at 0.55 microns, which is approximately the emulsion of the sun. Visible and reflective infrared remote sensing are parts of optical remote sensing. Optical remote sensing are mainly depending on the reflectance of the objects on the ground surface. Therefore, the information about the objects can be obtained from the spectral reflectance. Thermal infrared remote sensing. The source of the radiant energy used in the thermal infrared remote sensing is the object itself, because any object with a normal temperature will emit the electromagnetic radiation with a radiation about 10 μm. Microwave remote sensing. In microwave regions, there are two types of microwave remote sensing, that is passive and active. In passive microwave remote sensing, the microwave radiation is emitted from an object and is detected, while an active microwave remote sensing source is the electromagnetic radiation and detectors are placed on the sensors. Based on the number of bands used, the remote sensing can be divided into panchromatic remote sensing. In this remote sensing, single band image covering the entire visible spectrum or sometimes a wider range of 0.32 to 0.9 μm. Multispectral remote sensing. Multiple patterns using different regions of the electromagnetic spectrum such as optical, thermal or microwave regions in a relatively broad wavelength bands. Hyperspectral remote sensing. This is also called a narrowband image sensing. The extension of the multispectral remote sensing collected on dozens or hundreds of contiguous and narrow intervals of the spectrum is generally in optical regions. Scope of remote sensing. As an important resource exchange platforms, scientists and researchers can know the most up-to-date trends and seek for valuable primary source for reference. Remote sensing for the management of emergency GIS, geometric information to warn of the natural crisis, informatics and remote sensing. Extract and recover data from satellite images of optics and radar analysis. The application of the remote sensing techniques in earth sciences. The analysis of aerial and satellite images for the preparation of the spatial data. Update and improve the spatial database. Quick preparation for crisis management and environmental application of map application of GIS and remote sensing. Visual data modeling and augmented reality. Dynamic GIS, geometric design process. Monitoring of deformation based on SAR calibration data and integration of systems and sensors. Methods for preparation of DEM. Cartography and spatial information, that is visualization. Land surveying, industrial and underground. Standardization of spatial data. Geodesy. Training and communication in the sciences of geomatic. Components of remote sensing. The method of collection, processing and depreciation of remotely sensed data are very diverse image sensing system has following essential components. Energy source or illumination. The first requirement for remote sensing is to have an energy source which illuminates or provides electromagnetic energy to the target of interest. Sensors can be classified as passive or active carbon based on energy source they are using. Sensors which sense natural radiation either emitted or reflected from the earth called passive sensors. Most of the remote sensing sensors are passive in nature, which measure solar radiation reflected from the target. Interaction with the target. As the energy travels from its source to the target, it will come in contact with and interact with the atmosphere it passes through. This interaction may take place a second time as energy travels from the target to the sensor. Energy makes its way to the target through the atmosphere. It interacts with the target depending upon the properties of both the target and the radiation. The number of interactions are possible when electromagnetic energy encounters matter, whether solid, liquid or gaseous. Radiation may be transmitted, that is passed through the substance. Radiation may be absorbed by a substance and give up its energy largely to heating the substance. Radiation may be emitted by a substance as a function of its structure and temperature. All matter at temperatures above absolute 0 degrees Kelvin emits energy. Radiation may be scattered, deflected in all directions and lost ultimately to the absorption or further scattering as light scattered in the atmosphere. Radiation may be reflected. Recording of energy by sensor. After the energy has been scattered by or emitted from the target, we require a sensor which is mounted on the satellite orbiting in a space to collect and record the electromagnetic radiation. The sensors are popularly known by the electromagnetic radiation region they are. Remote sensing can broadly be classified as optical and microwave. In optical remote sensing, sensors detect solar radiation in the visible, near, middle and thermal infrared wavelength regions, reflected or scattered or emitted from the earth. On the other hand, when the sensors work in the regions of electromagnetic waves with frequencies between 10 to the power of 9 and 10 to the power of 12 Hz is called microwave remote sensing. This is highly useful as it provides observation of the Earth's surface regardless of day or night and the atmospheric conditions. The radar is an active microwave remote sensing system which illuminates the terrain with electromagnetic energy, detects the scattered energy returning from the terrain and then records it as an image. Intensity of the radar written for both aircraft or satellite based system depends upon the radar system properties and terrain properties. The sensor for taking observation common need to be mounted on a platform. This platform can be ground-based, airborne or spaceborne, that is satellite-based. The operational remote sensing systems are generally spaceborne. Resolution is a major sensor parameter which has bearing on optimizing utilization of data. There are four types of resolution. Spatial resolution. Sensor ability to image closely spaced objects so that they are distinguishable as separate objects. Spectral resolution. The spectral bandwidth in which the data is collected. Radiometric resolution. The capability of the sensor to differentiate the smallest change in the spectral reflectance or emittance between various targets. This is represented as the noise equivalent change in the reflectance or temperature. Temporal resolution. Temporal resolution represents the capability to view the same target under similar conditions at regular intervals. It is a time interval between image in collection over same geographical location. Transmissions, reception and processing. The energy recorded by the sensor has to be transmitted, often in the electric form, to receiving and processing station at the Earth, where the data is processed and stored in the digital form. Interpretation and analysis. Data is interpreted visually and digitally to extract information about the target which was illuminated. Specialized instruments or hardware and software are used for this purpose that are commonly known as image processing tools. The final element of remote sensing process is achieved when we apply the extracted information in solving a particular problem. Specialists working in each application field or theme generally are able to carry out this task. Image processing, also called digital image processing, has its handle. Digital data involves four basic steps: image correction or restoration. Image data recorded by sensors on a satellite or aircraft contains errors related to the geometry, the brightness value of the pixel. These errors are corrected using suitable mathematical model, which are either definite or statistical model. Image enhancement. Image enhancement is a modification of image by changing the pixel brightness value to improve its visual impact. The image enhancement techniques are performed by deriving a new brightness value of a set of surrounding pixels. Image transformation. The multispectral character of image data allows it to be spectrally transformed to a new set of image components or bands with the purpose to get some information more evident or to preserve the essential information content of the image for a given application with a reduced number of transformed dimensions. The pixel value of the new component are related to the original set of the spectral band via a linear operation. Image classification. The overall objective of image classification produces is to automatically categorize all pixels in an image into a land cover class or themes. A pixel is characterized by its spectral signature, which is determined by the relative reflectance in the different wavelength bands. Multispectral classification is an information extraction process that analyzes these spectral signatures and assign the pixels to classes based on similar signature. Remote sensing data products. The main interest of the social scientist and applied scientist is the data produced by remote sensing technique. The remote sensing data are of two types: pictorial and digital. These data products are digital data products. The digital data products give information in the form of an array of small cells having quantitative values, which is the function of electromagnetic energy radiated from all the objects within the field of view. A digital data product is called a digital image. A digital image is a two-dimensional array of pixels, that is the picture element. Each pixel represents an area of the Earth's surface and has an intensity value represented by a digital number and a locational address referenced by a rows and columns. The intensity value represents the measured solar radiance in a given wavelength band reflected from the ground. The location address is a one-to-one correspondence between the column row address of a pixel and the geographical coordinates, example, the latitude and longitude of the imaged location. The digital image is a vast matrix of numbers and is very often stored in a magnetic tape and in particular in a computer compatible tape, CCTs. The digital data can be converted into photographic image. Pictorial data products. The pictorial data products give information of objects on the Earth's surface in the form of photographs or images. The pictorial products provided by the aircrafts are called the aerial photographs. These are generally taken by sophisticated cameras which use visible portion of the electromagnetic energy. Therefore, aerial photographs give the exact view or the picture of the objects on the Earth's surface on reduced scale. The aerial photographs may be black and white or may be colored. It depends upon the camera used in the aircraft. The pictorial data products provided by the satellites are called satellite images. These images are generally taken by the sensors which use both visible and invisible portion of the electromagnetic energy. The satellite image can be black and white or can be colored. The black and white pictures or images are produced from each band of digital data. For a particular band, black and white images is generated by assigning different shades of grey, black to white, to its digital data. Likewise, a unicolor image, blue, green, red, etc. can be generated by assigning different shades of blue, green, red to a particular band data. When any three bands are combined, it gives multicolored imagery. If images are taken in blue, green and red bands, that is the visible portion of the electromagnetic energy respectively, they can be combined to give natural color image. If the images are taken in green, red, the visible portion of the electromagnetic energy, and the infrared band, the invisible portion of the electromagnetic energy, and the blue and the green colors are assigned to them respectively, and then they are combined together. It will produce a false color composite image. The false color composite image does not give the exact picture or the view of the Earth's surface like the aerial photographs. The layperson cannot visualize anything from the false color compact image. Only an expert can interpret it. The future of remote sensing. In the broadest sense, the measurement acquisition of information of some property of an object or a phenomena by a recording device that is not physical or intimate contact with the object or phenomena under the study. Example, the utilization of a distance as from the aircraft, spacecraft or ship of any device and its attendant display of gathering information pertaining to the environment such as measurement of force fields, electromagnetic radiation or acoustic energy. The techniques employ such devices as the camera, lasers and radio frequencies, receivers, radar system, sonars, seismographs, gravimeters, magnetometers and scintillation counters. A common expectation from remote sensing community is the ability to acquire data at high resolution if no cost come up with open resource support, and for creation of new applications by integration of spatial or aerial and ground based sensors. The development of smaller, cheaper satellite technologies in recent years has led to many companies to explore new ways of using low Earth orbit satellites. Many companies are forced on remote images, for example, to gather optical or infrared imagery. In the future, low-cost communication network between low Earth orbit satellites can be established to form the special remote sensing network. This network would integrate with large number of distributed grounds in service to establish a ground space remote sensing. In addition, satellites can easily cover large swaths of territory, thereby supplementing in the ground-based platform data distributions, and sharing would become very easy. Open, and sharing resources can promote the utilization of remote sensing and maximize its output. In recent years, open remote sensing resources have made great progress. Beginning on April 1st, 2016, all Earth imagery from a widely used Japanese remote sensing instrument operating aboard NASA Terra spacecrafts in late 1999 has been available to users everywhere at no cost. In open remote sensing resources, NASA was pioneer in sharing its imagery data. NASA has been cooperating with open source community and many NASA projects are also open source. NASA has also set up a special website to present these projects. In addition, some commercial companies like DG Global has also specially opened their data to the public. In future, more and more open resources will be available. Future applications in remote sensing will combine the valuable resource from the space or aerial or UAV platforms with the ground-based data. Summary. Remote sensing is a science when information is extracted from remote sensing data using some specific facts, whereas it is an art when information is derived through background or prior knowledge obtained through experience. Remote sensing analysis derive information remote sensing data using both scientific facts and their experience. As any other technology, even remote sensing is having advantages like large cover area, repetitiveness, easy access, the inaccessible, different application, different variation and scales of measurement, etc. The remote sensing also has disadvantages like expensive for small areas, training expenditure, calibration, human errors, etc. Remote sensing is basically a multidisciplinary science which includes a combination of various disciplines such as optics, stereoscopy, photogrammetry, computer, electronics and telecommunication, satellite launching, etc. All these technologies are integrated to act as one complete system in itself known as remote sensing system. There are a number of stages in remote sensing process and each of them is important for successful operation. Remote sensing also involves the sensing of emitted energy and the use of non-imaging sensors, energy source of illumination, radiation and the atmosphere, interaction with the target, recording of the energy by the sensor, transmission, reception and processing, interpretation and analysis, application.